Volume of a solid of revolution. What a volume of a solid revolution is basically the area between two curves revolved around a line. The line could be a line like this, or it could be the axis. So it basically is a solid, and you find the volume. So the volume of a solid revolution comes in two methods, the disk method and the washer method. I'll go over the washer method shortly. So the formula is simple for the disk method. It's just pi times the integral of the function squared dx. dx if it's revolved around the x-axis and it's in terms of x, and dy if it's revolved around the y-axis and it's in terms of y. And these are the bounds, right? So let's do a problem. F of x equals x squared revolved around the y-axis from y equals 0 to y equals 2. So you take the equation volume equals pi times the integral of c to d of the function squared dy. Since you do dy since it's revolved around the y-axis. So what you would do is plug in, you use the equation y equals x squared, and you will manipulate it so you could do it in terms of y. So you square root both sides and get x equals radical y. So you plug in radical y and you square it dy. You take the integral of y, and the integral of y is y squared over 2 times pi. And you use the fundamental theorem of calculus using the bounds and subtract 2 when you plug in 2 and subtract it when you plug in 0. So 2 squared over 2 minus 0 squared over 2. 2 squared over 2 is 2 minus 0, which is 2, which is equal to 2 pi. So now the washer method. The washer method is basically when you have two regions revolved around a line, but it has a hole in the graph. So what it basically is pi times the integral of the outer radius squared minus inner radius squared dx. dx if it's in terms of x, dy if it's in terms of y. dx, remember, it's revolved around the x-axis, and dy is revolved around the y-axis. So the outer radius would basically be the top portion of the graph, right, subtracted from the equation of the line it is being rotated around. So the equation of this line is y equals 0. So it's y equals x. So x minus 0, which is equal to x. And the inner radius would be the bottom portion of the graph minus the equation of the line that you're rotating the graph around. So this would be x squared minus 0, which is still x squared. So let's do a problem. Find the volume of the solid that results when the region bounded by y equals x and y equals x squared from x equals 0 to x equals 1 is revolved about the x-axis. So this is how the problem will look like. It's basically the same problem we saw earlier. So you have the region and you're rotating around the x-axis. The formula: volume equals outer radius squared minus inner radius squared in terms of dx, because it's rotated around the x-axis, right? And the bounds are 0 and 1. So 0 and 1. Oh, I forgot to write pi. Don't forget the pi. See, I almost forgot. So pi, and the outer radius is basically y equals x minus the line, the equation of the line that you're rotating around, and that is y equals 0. So y equals x minus 0, which is x minus 0, which is equal to x. And the inner radius is x squared minus 0, which is x squared minus 0, which is still x squared. Outer radius, inner radius. So the outer radius is x squared minus inner radius is x squared squared, because you gotta carry the squared dx. So volume equals pi, we go 0 to 1 of x squared minus x to the 4th dx. So let's solve the integral. X squared minus x to the 4th, which is pi times x to the 3rd minus x to the 5th over 5. And we do the fundamental theorem of calculus. So you do 1 cubed over 3 minus 1 5 minus 0 cubed over 3 minus 0 5. This is just 0. So basically the answer, 1 cubed over 3, so it's 1 third minus 1 over 5 times pi, which is 2 over 15 pi.